Who's my favorite student? Sadly, it's none of you. Good old Ann. Okay, number one. I need to change. I used to be fussy on sig figs. I'm not anymore. So include the units that I'm still fussy on, but I need to remove that heading. I need to go through my quizzes and update them. I'm going to do the second part first for 1 mark. What's the unit of force? What do we measure force in? Newtons? Or what? Technically, kilogram meter per second squared. Because F equals what? There it is. Mass times acceleration. This is what we used to write. And then there's an international committee that decides on units and things. They said, let's name this one after Sir Isaac Newton because it's less writing, and this person should probably have a unit named after him. Anyways, what did you guys say? What's a definition of a force? If you said the mathematical definition, I would totally live with that. Sure. I also gave you an English definition in the very first sentence of lesson 1, I think. I said a force is a... Nobody use it? Sorry? Push or a pull. So if you said... And I think I might have said, that's a terrible physics definition. A quantum physicist would glare at me. It's an interaction between two objects when they extremely left. It's a push or a pull at the higher level that we're looking at. Okay. Number 2, what force? Net force. So, sorry, I should say then 1 mark for 1 mark for your definition of force, 1 mark for the correct answer. What force? A net force. I can go straight to F equals ma. I'm going to be very blatant on your test, on the written section. The very first question on the written section, it's going to contain the magic phrase net force. And I'll even be more blatant. I'm going to give you 2 of force, mass, and acceleration and ask you to find the third one. So if I ask you to find acceleration, you use Alex's theorem. If I ask you to find the mass, I'm going to pretend that you can cleverly figure out how to get the m by itself here too, without me having done an entire lesson on it. How would I get the m by itself? Okay. Here they just want the force. I can do this in my head. 1,200 times 2, 2,400 newtons. Yes? 1 mark. I noticed in number 3, net force, but I also noticed it's worth 3 marks, which probably means I'm going to find something in order to find something. So the first thing I did is I wrote down F equals ma. And then I walked through and I said, do I know the mass? Yes. Do I know A? No. Or do I? Then I said, okay, even though this question said find the net force, you know what I'm going to spend most of my time finding? So my high-tech staying organized system, I went, okay, let's give myself some room and just kind of separate them. And now I went to my DFIC approach. I went A equals question mark. Ooh, I saw at rest, so I said VI is 0. I saw VF was 770, and I saw the displacement was 1.5. I said, oh, I can find A by going VF squared all over 2. What happened to the minus VI squared? It's 0, and I got lazy and didn't feel like writing it. So I said it's going to be 770 squared all over 2 times 1.5. I got out my trusty calculator. I said, is this a fraction? Only one thing on the top, so I don't need, whoop, that's wrong. Only one thing on the top. I don't need brackets around the top. Do need brackets around the bottom. And I got a really big answer, and at first I started to get nervous, and then I said, wait a minute, this is an artillery shell. Probably has a big acceleration. What distance is there in this question? 1.5 meters is about this. I'm eyeballing it, yeah? And it's going from 0 to 770. That's twice the speed of sound. Should it be a big acceleration? Yes! So I actually got more relaxed. At first I was nervous, and then I went, oh, no, that's probably right. I'm going to use my answer button. So I wrote A equals 198,000, but I'm just going to transfer my answer button. In fact, the way I usually show that, I draw an arrow. That's to say, I'm going to stick it in there now. F equals 65 times, sometimes I'm so lazy, I'll even write ANS answer button to let myself know that's what I'm doing. And I got that, which is big. It's an artillery shell. If an artillery shell hits something, do you think it applies a fairly big force? Yes. Yes. So you could write that up. I think I'm going to go scientific notation. 1.28 times 10 to the 1, 2, 3, 4, 5, 6, 7. So I wrote it as 1.28 times 10 to the 7th newtons. If you got that, 3 out of 3. So that's how I would mark this. I would look at this question. If you got it right, 3 out of 3. If you got it wrong, then I would probably do something like this. Half mark if you had written F equals ma, because you've learned enough physics that recognizing that that's how you'd find the force should be rewarded. I would give you a half mark if I saw that equation somewhere. Half mark for those numbers. Half mark if I saw the equation. Half mark for sticking in 65 times that. And a half mark for the answer. Here's what that means. If you got the acceleration wrong, but you took your wrong answer times 65, I would still give you 1.5 out of 3. You would pass the question because you had done the physics of the forces portion, right? So I should reward some of that. Number 4, a what force? I went, A equals F over M. I rewrote it in my head without writing F equals ma first. So it's going to be 12 divided by 1.2, 10, yes? I put the dot just to go to 2 sig figs to look impressive, but I'm not that fussy if you didn't put the dot after the 10. 1 mark. Average acceleration, number 5. So I said, well, how did I know to go A equals instead of F equals ma? I saw time, I saw a velocity, I saw mass, but I didn't see enough otherwise. So I said, I think I'm going to find it this way. From rest, 3.2 times 10 to the 4th, t equals 32. I said A equals VF minus VI over t. It's going to be 3.2 times 10 to the 4th all over 32. Actually, didn't even bother writing the VI since it was 0. I said it's just going to be VF over t in this case. Is it 100 even? No, 1,000. No, is it 100? It is 1,000 meters per second squared. About 100 Gs. This is not a manned satellite. This would be an artificial satellite. B, the what force? Net force. Okay. 4.5 times 10 to the 4th times 1,000. I think you're going to get 4.5 times 10 to the 7th newtons, or 4, a 5, and 6 zeros. But I figured I could just do the scientific notation part in my head because multiplying by 1,000. Now, can y'all look up for a second? As far as I'm concerned now, I could ask you part B without walking you through part A first. I might hint by making it a 2-mark question to let you know you have to find something in order to find something. Okay? I think that would be fair game now. A what force? A net force. Wants me to find D. 2 marks. Probably going to have to find something in order to find something. From rest, VF is 12. If I wanted to find the displacement, what else would it be nice if I knew? Well, either time or acceleration. Which one of those do you think I can find from the information they gave me? So I said, okay, my high-tech system is, if it's a blank I need to fill in to find the original answer, I actually draw a blank, saying I got to fill that in. I think I'm going to use Alex's theorem, A equals F over M. It's 1.6 over 6.4. Is the acceleration 0.25? So I'm going to go D equals VF squared minus VI squared, which is 0, all over 2A. It's going to be 12 squared all over 2 times 0.25. I can do that in my head. 12 squared is 144, divided by 2 is 72, divided by 0.25, 72 times 4, 288? Yeah. meters. Again, if you got that, 2 out of 2, as long as you showed some work. Otherwise, I would probably do something like this. Half mark if I saw that, half mark for that. I would give you a half mark if I saw that you would recognize that that's how I'll find acceleration, and a half mark for finding the acceleration. Oh, now they want me to find time. You know what? Here I'm going to have to use my answer from A, I think, to find, well, I think I'm going to go this. Time equals VF minus VI over A. Or I could go time equals the square root of 2D over A. No matter what, I'm using the acceleration from that I found. So no matter what, I'm going to have to do it that way. So I chose to go with this. What is it going to be? 12 divided by 0.25. 48? No? Yes? Yes? Okay, so it helps if you respond. 48 seconds. Here, for 2 marks, I would argue probably this should have been a 1 mark question, but whatever. I would probably go 1 mark for the equation, half mark for the numbers, half mark for the answer. A book is sitting on a level desk. Which of the following statements are true? How many marks is this question worth? How many statements are there? Probably 0.5, half mark for each statement. That'll work. True or false? There are no forces acting on the book because the book is not accelerating. Are there what forces are acting on the book? Ah. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. I think that's true. I think forces are, that's a long-winded way of saying I think the forces are balanced. The net force on the book is equal to 0. Is it accelerating? Then it has to be 0. If it was accelerating, then it couldn't be 0. Friction is what's holding the book up. Oh. If your desk was made of ice, as long as it was level, could the book still rest on it? Yeah. So is friction required to hold the book? No. So false, true, true, false. Be your answer there. Number 8. What's the third word I used in this question in number 8? Weighing. Did I say mass? No. I said weighing. This here is mg. If you said the mass was 588 kilograms and you used 588 for m, that person's not fitting in an elevator. Sorry, that person's well over 1,000 pounds. So I will do that at least once on your test. Rather than give you an object's mass, I'll give you its weight. How would I figure out the mass? M is going to be 588 divided by 9.8. And I think I made this one work out nice. What was it? 60 even? I might not always make it work out nice. You might just use your answer button, but okay. So it wants me to find the scale reading. No, it doesn't. What does it really want me to find when it says find the scale reading? Newtons? No. Yes, it's a force, but normal force. This is a job for a free body diagram. I'll do A on the left here. I have gravity down. Am I going to draw the normal force bigger, smaller, or the same size as mg? How do I know? Why? Got to be fussy, not going up. Accelerating up. Newton's laws don't tell us which way we're going. They only tell us which way we're accelerating. By the way, how could we be going up and have gravity winning? Yes, I would feel fair game as a mini curveball, but I would feel no problem saying the elevator is going up but slowing down. And I would expect you to clue in, well, if it's slowing down, we're accelerating downwards. Gravity's the winner. Here, though, it's going to be normal force minus winner minus loser equals ma. So I guess the normal force equals ma plus mg. It's going to be 60 times 1.2 plus. I was really lazy. I just wrote 588. You could have gone 60 times 9.8 mg, but I'm pretty sure that's going to be 588, so save myself some time. 60 times 1.2 plus 588. Yeah, 660 units newtons. I would give you half mark for that equation, half mark for getting the normal force by itself, half mark for the numbers, half mark for the answer. If you didn't realize that that 588 wasn't a mass, if you used it as a mass, then you would have gone like this. 588 times 1.2 minus 588 times 9.8. You'd get a weird answer, first of all. Oh, sorry, it's plus, Mr. Duick, not minus, it's plus. If you said 6,468, I would give you 1 out of 2. And I would also hand you a Verizon application. Which way are we accelerating in B? Who's winning? I think I can just imagine this diagram changing without redrawing it. If you want to, you certainly can. In my homework, I might just imagine, oh, the downward arrow is longer. I think here my equation is going to be mg minus Fn equals ma. And this is where I introduced to you something that we nicknamed the swappy dance to get the normal force by itself, because it's got a minus sign in front of it. And so I'm going to get mg minus ma, and I'm going to write the equals Fn on this side because that's where we're used to seeing it. So it's going to be 588 minus 60 times 2.25. Do you get 453? What if instead of asking for your scale reading in newtons, what if I said, no, they're standing on a kilogram scale? How would you convert that to what a kilogram scale would display? Yeah, the scale would be reading 46.2 kilograms instead of 60 kilograms. This person feels lighter. Anyways, 453 newtons. Ooh, what's the key phrase in B? Sorry, in C. Yeah. Okay, read that carefully. Constant what? So, what does constant velocity tell me? So what does that tell me? So you know how big the normal force is? 588. This person feels normal. That's not meant to be a pun, but this person feels they're normal, if I can use the word normal in two different... Sorry? No, because you can also do an equation. You can say, well, we're moving up. You could have let the normal force be a winner. I will almost always give you a velocity just to tempt you to put the 12 in for A. But it's, no, Verizon, that's meters per second, not meters per second squared. Anyways, what about D? Yeah. If you just said that, I'd give you 2 out of 2. I'm not going to punish you for understanding the physics well enough not to derive it. If you needed to derive it, you would say, who's winning? Gravity. Who's losing? Normal force. What's that equal? ma. You would swappy dance, and you would get ma minus mg, and you would get 60 times 9.8 minus 588, and you would end up going 588 minus 588. You would have just proved, oh, the normal force will be 0 if I'm accelerating down at 9.8. But if you were clever enough to say it's 0, I'm fine with that. Okay? So same marking scheme for this one. Half mark, half mark, half mark, half mark. But as always, if you got the right answer, you get 2 out of 2, and then I go looking for part marks. Here, 2 out of 2, here, 2 out of 2. You give yourself a lovely score, please, out of 23.